Hello students, welcome to IIT, Akshar IIT Foundations. This is Ghaffar sir, your physics faculty. Let's start our session. So in the last class we discussed that multiples and submultiples. Today we discuss dimensions and dimension formulas. Okay, so let's start the session. Yes, I will start the session. Dimensions and dimensions formula. Dimensions and dimensional formula. So this is our today's topic, isn't it? So before explanation about this dimension and dimension formula, I'll recall one concept, that is nothing but fundamental quantities. Tell me, what are the fundamental quantities? You know the fundamental quantities are 7 or 8. Yes, 7 only correct. 7. So first one is what? Mass. First one is mass. First one is what? Mass. Second one is length. Second one is length. It is not appear clearly. Second one is length. Third one is time. Fourth one is temperature. Fifth one is current. Sixth one is amount of substance. Amount of substance. And seventh one is luminous intensity. So these are the 7 fundamental quantities, and the units of these fundamental quantities: mass, for mass kg, for length meter, for time second, temperature Kelvin, current ampere, amount of substance is mole, and luminous intensity candela. So this is very well, isn't it? Very well. Now here, why I recall these fundamental quantities, because here to write or to explain dimensional formula, so only these physical quantities only useful, so that I recall these fundamental quantities. Now let's start what is mean by dimensions. Dimension means any physical quantity, how much it is participating in any other physical quantity. Okay, once again I am repeating, any physical quantity, these fundamental quantities, how much they are participating, or powers of these fundamental quantities in any physical quantity is known as dimension. Once again I am repeating, the powers raised in any physical quantity by these fundamental quantities is known as dimension. And now, what is mean by dimension formula? The dimension formula means writing any physical quantity in terms of these fundamental quantities is nothing but dimension formula. Okay? So once again I am repeating, dimension formula means writing any physical quantity in terms of these fundamental quantities is known as dimension formula, and the powers of the fundamental quantities in that particular physical quantity is known as dimensions. I think you got it. So that's it, our chapter. That's it, our concept. Understand? So now, by doing the formulas, by doing the examples, you will get very clear of this concept. Okay? Shall I take the examples one by one now? So now I will write examples here. So if I write example, so for example, very small example, very simple example I will take here. The simple example is area. Area is a physical quantity, isn't it? Area is a physical quantity. When you are writing the area is a physical quantity, what is the formula for area? length into breadth. This is a formula for area. Now, how do you write this area physical quantity in terms of fundamental quantity here? So now, this is the area. When you are talking about area is equal to length into length. Length into length means, so length into length means it is become L square. So is any mass contribution is there? No mass contribution. So mass is mass power 0. Is there any time contribution? No time contribution. So that time power become 0. So this is your what? This is your dimension formula of what? This is called dimension formula for what? Area. And this total equation is called dimensional equation. Dimensional equation. This total equation is known as dimensional equation. In that, this simple part, this part is called dimensional formula. Dimension formula. Dimension formula, and these powers of this fundamental quantity, the powers of these fundamental quantities are called dimensions. So these powers are called powers of fundamental quantity. Fundamental quantity. Powers of fundamental quantity is known as dimensions. See here, once again I am repeating, this total equation is called dimension formula. Dimensional equation. This part is called dimension formula, and powers of these fundamental quantities is known as dimensions of that physical quantity. Okay. So here I got clarity. You got clarity, right? Now here the thing is, if you see that carefully, how it is look like, how it is we are representing here. We are representing the dimension formula, if you observe, in a square bracket. So that is the main point here to write a physical quantity as a dimensions. So every time you must represent in a square bracket to represent the what? Dimension formula. That is the main thing here about this concept. Okay. Now I will give one more example. You will get more clarity. So now for that I will take out here these fundamental quantities. So one more physical quantity I will take volume. I am taking volume. He is a physical quantity. When you consider volume as a physical quantity, what is the formula for volume? Volume formula is length into breadth into height. Length into breadth into height. So now I wish to write dimensional equation, dimension formula and dimensions. 3 points. How many points? Dimensional equation, dimensional formula, dimensions. Now let us write dimensional equation first. When you are writing dimension equation, the physical quantity you must show in a square bracket. So I will show in the square bracket volume. Now volume is the volume physical quantity. Is there any mass contribution? No mass contribution. Since mass power become how much? 0. Is there any length contribution? How many? 1, 2, 3. So L length power would be 3. Is there any time contribution in the volume? No time contribution, since time become 0. So finally this is your volume dimensional equation. So this completely is called what? Dimensional equation, and this part is called dimensional formula, and powers raised in the physical quantity, whose physical quantity, fundamental quantities, powers, we will consider as dimensions. Here what are the dimensions here? 0. Who is having 0? Mass power 0, L power 3 and time power 0. So that is how the dimensions for what? Volume. I hope you got clarity, isn't it? Better note down, everyone. Next, let me take one more thing, one more example. The one more example, density if I take, density, mass density. If I take mass density, what is the formula for mass density? Mass density means mass per unit volume. Mass per unit volume. Mass density means what? Mass per volume is known as mass density. Now after knowing this formula, let us write in terms of fundamental quantity. So fundamental quantity means mass is m, volume nothing but L cube, right? So now let me write this density dimension formula. So density is equal to, is there any mass contribution? Yes, mass power is 1. Is there any length contribution? Yes, L power 3. Why L power 3? Because it is in denominator. If you bring it to numerator, the power become inverse. So L power minus 3. So now T power 0. So this is your total what equation? Density dimensional equation, and this is representing the dimension formula, and dimensions are what? 1, minus 3, 0. These are the dimensions for the density. So this is about your topic. I will give one more example here. Can I take out? Yes, I am taking this. You can take other examples here. The other examples are, let us take velocity. Velocity is a physical quantity. What is the formula for velocity? Velocity is equal to distance or displacement by time. This is the velocity formula generally. Displacement is nothing but L, time is nothing but T. So now you can write a dimensional equation as velocity is equal to, is there any mass contribution? No mass contribution. So you can take m power 0. Is there any length contribution? Yes, in the velocity we have a length contribution as 1, and time contribution is how much? It is a denominator. When you have to bring it to a numerator, it's become what? Minus 1. So this is your what? This is your what? Dimensional equation for what? Velocity, and this is the dimension formula for velocity. These powers of the fundamental quantities is known as dimensions. Understand? Let me give one more example. Acceleration. So when you are talking about acceleration is nothing but velocity upon time. Velocity means, if I take formula, meter per second. Now let us take acceleration dimension formula here. Acceleration is equal to, so already you know, here m means meter is nothing but length, so L power 1. First of all, write mass terms. no mass contribution. So m power 0, L power how much? 1, T power how many? 2 square times kada, but it is a numerator. When it is come denominator, it is become T power minus 2. So this is your acceleration dimensional formula. Once you know the acceleration, even you can write for force. Force here, force formula is mass into acceleration. What is the formula? Mass into acceleration. When you write mass into acceleration, so mass is kg, acceleration is meter per second square. So now force dimensional equation is kg means m power 1, meter means L power 1, time it is denominator, when it is bring into numerator, so it is become 10 power T power minus 2. So this is the way we can write the dimensional formulas. And similar way, let me write dimensional formulas for our fundamental quantities also. Everything we are expressing fundamental quantity, but the fundamental quantities also we can write the dimensional formulas. Let me write dimensional formula for fundamental quantities. So can I take out? So the thing is, so you know fundamental quantity, first one is mass. So dimensional formula for fundamental quantities. Formula for fundamental quantity. Fundamental. It's not mental, fundamental. Fundamental quantity. First one is mass. Mama, mass. First one is what? Mass. So here mass, only mass contribution in mass, only mass contribution present, right? So here, then mass power 1, remaining all fundamental quantities contribution is 0. So you can write L power 0, T power 0. So this is your dimensional formula for what? Mass. And similar way, length. So in a length, mass contribution nothing, time contribution also nothing, remaining all contribution of fundamental is nothing, since this is become m power 0, L power 1, T power 0. Similar way, length, after the length, time kada. So time, so when you are talking about time, no mass contribution, so m power 0, no length contribution, time power 1. So time power 1, T, simple T, time power 1, both representing the same. Next, let us take one more fundamental quantity. Temperature, I will take. Temperature. Temperature means m power 0, L power 0, T power 0, K power 1. So you can add one more physical quantity also, because the fundamental dimensional equation nothing but expressing any physical quantity in terms of 7 fundamental quantities. So, but here every time showing 3, even you can write all the fundamental quantities, but if you write all the fundamental quantities, it become very lengthy. Whatever the necessity fundamental equation, at least minimum 3 you can write. Fundamental quantities, at least 3 you can write here. So this is not 6 students, this is 0. Minimum 3 fundamental quantities participation you can write in a dimensional formula. So this K power 1, K power minimum is nothing but temperature. Next, similar way, one more. What is one more here? Amount of substance, right? or current you can take. In the current, mass power 0, L power 0, T power 0, A power 1. So here A power is current also fundamental quantity. So that is the reason it having power A. Next, let us take after that amount of substance. Amount of substance dimension formula, which is equal to no mass contribution 0, L power 0, T power 0, amount of substance actually mole power 1. Next, finally, luminous intensity. Luminous intensity. When you write luminous intensity, that is equal to m power 0, L power 0, T power 0, CD power 1. So that is the way expression of what? Fundamental quantities. Now we'll do practice some questions from your material. So I hope you everyone having this prompted material. So open that material and see page number 27, fifth practice sheet. Let us discuss first concept based questions. Let me discuss concept based questions. Now I will take out this thing. I am taking this. Now let's discuss problems here. Everyone compulsory read the material. Okay. Is there any missing terms? You can ask me. So first we'll do concept based question. The first question is the symbol to represent the unit of thermodynamic temperature. The symbol to represent thermodynamic temperature. So what is the thermodynamic temperature symbol they are asking? So unit is nothing but Kelvin. So Kelvin is Kelvin unit we represent with Kelvin K. So our answer is what? Second option. Our answer is what? Second option. Next, similar way, the symbol to represent unit of electric current. The symbol to represent electric current is actually unit. Only they are asking unit. You can write unit for only AM. A you can write. So then first option it become. If it is the fourth option is wrong. So only they are asking unit. The symbol to represent the unit of electric current is only A. It is not I. For writing the dimension formula, you can represent A and I, not an issue. But when are talking about unit, you must show with A only, not with I. So got clarity? So if any corrections, if any wrong key is there, so strike out, keep it as 1. So next same way, third question. The symbol to represent the unit luminous intensity. The luminous intensity symbol is CD. CD. So what is the option ours? Second option. It not capital C and D. It is small caps. Lower order CD you must take. Next similar way, the symbol to represent the unit of quantity of matter. The quantity of matter symbol is MOL, small MOL. So small lower order you must take here MOL. Since our answer is what? Third option. Our answer is third option. Symbol they are asking. Symbol is MOL only, not total name. Now, fifth question, look at here, fifth question. An expression showing the powers to which fundamental units are raised to obtain one unit of derived unit is called. So, simply, what is that? Dimension formula. So, it is an expression showing powers of the fundamental quantities to express any derived quantity is known as what? Is known as, yes, you are right, it is a dimension formula. And next, one more thing. Yeah. So, dash of physical quantity are the powers to which the fundamental units to be raised obtain one unit of the quantity. So, actually, what is asking? Dash of the physical quantity. So, this is also showing the same kada. So, it is actually dash of the physical quantity are the powers to which unit are to be raised to obtain one unit of the quantity. One unit of the quantity. So, simply it is the dimensions. Dimensions of the physical quantity powers raised. So, answer is what? First option. It is sixth question answer is first option. Similar way, the general formula for acceleration. So, here look at here, acceleration. Acceleration is equal to velocity upon time. So, once verify which option is giving the same thing, velocity per unit time. So, see here the fourth option doing the same thing. Here velocity, actually it is a change in velocity. When you talk about actually, when you are talking about, we will take this as change in velocity. When you are discussing the kinematics, we will explain this is deeply, don't get worried. And next, the general formula for momentum. So, eighth question, this is actually which question? Acceleration kada? This is seventh question. Eighth question is general formula for momentum. Momentum is equal to what? Mass into velocity. Mass into velocity. So, now look at the general formula here is, which one is showing the same thing? Yes, the fourth option is showing the same. So, fourth option is our answer. Next, similar way, general formula for force. Ninth question, force formula. Already we discussed this force formula, mass into acceleration. Mass into acceleration, shortly we write MA what? Ma. Next, general formula for impulse. 10th question. Impulse. Impulse we can write in two ways. First one is force into time. This is the first thing. Next one is change in momentum. The change in momentum also showing the same. So, which one is we are having? You can keep. So, what is the general formula impulse? So, here force into area they given. So, you can take this answer. Even this answer also is correct. Change in momentum is also our correct answer. Next, let us discuss exercise questions now. So, JE means the first question is dimension formula for area. Tell me dimension formula for area. Yes, the dimension formula for area. Now, can I take it this? Yes, I will take it. So, don't get worried. The how these formulas you are having, don't get worried. By keep on learning, you will come to know how these formulas existed. By daily practice, you will come to know. Don't get worried. Okay. Now, let me discuss exercise questions. JE1 first question is dimension formula for area. So they are asking dimension formula area. For that, first of all, you must know the formula. Formula for area is length into breadth. When you write length into breadth, length terms, only length terms we have. So how many times length we have? 2 times. So that the area dimension formula is m0 L power 2 T0. So the answer is what? Yeah, third option is correct. Similar way, dimension formula for volume. Volume dimension formula. Formula is what? Length into breadth into height. So the dimensional formula become what? M0 L power 3 T power 0. Understand? So it is your dimensional formula. So for now, I will stop the session. So I think you got clarity how to write this dimension formula, how to get the dimension formula. So children, I will stop the session. Bye bye.